Hi, everybody. We are going to start going over your notes for class today. At this point, you should have already done your warm up for the day, which is actually part of your classwork and set of notes that we started last class. So, just as a reminder, if you need to find anything that we're working on, you're going to go to the classwork tab. We're in Unit 3, Stretching and Shrinking, and when you click on those student notes, it's going to open the same copy of the notes that you were working in the other day. So anything that you had typed into those notes, any examples you completed should be there. If you didn't get to your notes the other day, you're going to want to go back and do the video from earlier this week because everything that we're doing today is based on what you learned how to do last class. So your warm-up, just so you guys know, is page 3. I know I was looking at some people's notes, and your work from pages 1 and 2 did kind of extend down onto page 3, so it's possible that this starts maybe partway down page 3. But your warm-up is that using money to understand fractions, decimals, and percents page. And we'll be working on page 4, which is called Similar Figures, Making Copies. I'm going to try to keep this a little more brief than our video from earlier this week. I know that warm-up was a little bit longer than what we would normally do on a distance learning day. And there is one other activity that I'd like you to try to get to today. So I'm going to try to keep it a little more brief. Here we go. Okay, so the directions are: use what you know about finding percent of a number to enlarge or shrink each image. So when you see this image here, you'll notice that you can't type on anything, okay? It's a drawing. So what you want to do is double click on that picture, and it's going to open up the drawing tools so that you can actually complete these questions. So what we're going to do first is take each figure, A. So in the first example, it's a triangle. And first, we're going to reduce the shape to 50% of its original size. Then we're going to take the original and enlarge it to 200% of its original size. And like the direction said, this is just applying what we learned the other day with finding percent of a number. So let's go ahead and get started. Okay, I think I can, nope, not border color. I think this is what I'm looking for. There we go. Okay, so again, I'm still gonna try to highlight my work in yellow for you. You guys don't need to do that on your notes, but if you'd like to, you're obviously more than welcome to. They're your notes. You can fill them in however you'd like. Okay, so let's start by shrinking figure A, the triangle, to 50% of its original size. There's one thing that we haven't talked about yet, and we will talk about it later, probably next week, but it is worth mentioning now. It seems pretty obvious which sides kind of match up in these images because the triangles have all been positioned the same way. Sometimes it won't be so obvious. So what you'll hear me referring to is something called corresponding sides. And what that means is, for example, the side on triangle A that matches up with that same side on triangle B, and it also happens to match up with this side on triangle C. In this specific example, we're talking about the side that meets the base of the triangle in a right angle. But we're talking about sides that are in the same position in these similar figures. Okay, so here we go. We're going to shrink this 6 centimeter side by 50%. So if you remember back to your notes the other day, when we're finding 50% of 6, we're gonna change that 50% to a decimal, which is 0.5. We're multiplying it by 6, and we get 3. I'm not going to write out the work for each one of these. To be honest, cutting something to 50% of its original size is pretty simple. You're really just cutting everything in half. If this was a more kind of complicated example, I would go ahead and show that work. But especially in this format, it's a little more difficult to do. Happy to show you that at some other time if you would like. Okay, so we're going to go ahead and find 50% of 8. If you're using a calculator, 0.5 times 8, that's going to be 4. And we'll do this last one. 50% of 10 is going to be 5. Okay, and we'll worry about the area and perimeter part in just a minute. Okay, moving on to figure C, we are taking our original figure and enlarging it to 200% of its original size, which means if you change 200% to a decimal by moving the decimal point twice to the left, we're really multiplying all of those side lengths by 2. So there's not even really much decimal work to be done here. The other way that you can think of this is obviously doubling. So we're going to double our corresponding sides. So we're going to double 6 to get 12. We're going to double 8 to get 16. We're going to double 10 to get 20. Okay. While we're at it, let's go ahead and take care of these rectangular examples as well. We'll get into the area and perimeter in just a minute. Okay, so, oops. Sorry, I thought I had labeled all of these A, B, and C. Okay, we're working on rectangle D. Sorry about that. All right, so rectangle D, the original sides are 12 and 8. We're going to cut those by 50%. So we're finding half of 12, multiplying by 0.5, same idea. So this is going to be 6 by 4. And when we go to enlarge this to 200%, using these original measurements, we are going to double them, getting 24 by 16. Okay. All right, so let's go ahead and get into the area and perimeter work here. Just because we might as well get that all done while we're working in this drawing part of our notes, and then we can close the drawing, our work will be saved, and we can move on. Okay, for the triangle examples, remember when you're finding the area of a triangle, you want to multiply the base times the height of the triangle. Remember, those are your two sides that meet in a right angle. So this is a right triangle, easy to identify. Okay, it's the base and then that left-hand side in all of these examples. And then you have to divide by 2. Don't forget that part. Because remember, if we were to just multiply 6 by 8, that would give us the area of a full rectangle that was 6 by 8 centimeters. But we've cut that rectangle in half by finding the triangle. So that's where the cutting in half comes from. I know we're digging way, way back. I promise there's not a ton of area work in this unit. There's just a tiny little bit. Okay, so here we go. We're doing 6 times 8, which is 48. We're dividing our answer by 2. So the area here is 24 centimeters squared. I'm going to be fancy and do the exponent work here. I'm not sure. Yeah, I'm not sure how easy it is to do an exponent if you don't know the shortcut key to do it. So I will share with you what I just did. To make that 2 into an exponent, I highlighted just the number 2 and I hit Control and the button with the period and the less than sign. And you can just kind of toggle back and forth. It's not a big deal. So don't worry if you can't get that to work. And again, it might be different on a Chromebook. So nothing to worry about. I'm just being fancy. Okay, let's do the perimeter. Okay, 6 plus 8 is 14 plus 10 is 24. Interesting. So I think that's just sort of a coincidence, but the area and the perimeter happen to have the same number. Perimeter does not get an exponent because that's just like if you walked around the outside of the triangle. Okay, let's go ahead and find the area of our second triangle. So what we did here was we cut the size of the triangle in half. So you might think that the area will be cut in half also. Let's see. Okay, so we have 3 times 4, which is 12. We have to cut that in half because it's area. All right, so 3 times 4 is 12. So our area actually here is 6. So it's not cut in half like we maybe thought would happen. Interesting. Now what's going on with the perimeter? 3 plus 4 is 7, plus 5 is 12. So interesting, the perimeter did end up getting cut in half when we reduced the shape to 50%. Wonder what's going to go on over here when we enlarge the shape to 200%. Okay, area. Not going to lie, I'm going to need to pull out my calculator. And it's totally fine if you do too. All right, so for area, we're going to do 12 times 16. That's 192. We need to divide that in half, and that is 96. Okay, 96 centimeters squared. Well, that didn't double. That's not double 24. I wonder what's going on there. Let me know if you find any patterns. A challenge to you folks. All right, and we'll do the perimeter as well. So 12 plus 16 is 28, plus 20 is 48. So the perimeter seems to be kind of following a pattern that we might expect, right? So when we cut the size of the shape in half, the perimeter was cut in half. When we doubled the size of the figure, the perimeter was doubled, but that didn't go on with the area. Let's see if the same thing is going on with the rectangles. Okay, so, all right, rectangles, super simple, just multiply the length by the width. So our area here is 12 times 8, which is 96 inches squared. Sorry, my dog's next to me. She's being grumpy. All right, perimeter. Careful when you're finding perimeter. Make sure that you find the total of all 4 sides, even though only 2 of them are labeled. So the way I like to do this, if you've got 2 sides labeled there, go ahead and add up the 2 sides that you see. 12 plus 8 is 20. And then you can just double that because we have another 8 and another 12 that we need to add. So this perimeter would be 12 plus 8 is 20 times 2 would be 40 inches. And again, perimeter doesn't get an exponent. All right, let's go ahead and work on the other 2 figures. Area, 6 by 4, so this is a 24 inch squared area. Didn't get cut in half. What kind of patterns are we picking up on? And I will tell you, yes, there's definitely a pattern. Okay, and perimeter, I'm going to use my trick again. 6 plus 4 is 10. I'm just going to double that, and that is 20. Okay, and last but not least, 24 times 16. I'm not shy to use my calculator. 24 times 16, 384. Inches squared. And our perimeter, 24 plus 16 is 40, times 2 will be 80. Okay. I'm going to go ahead and save and close that. And this will all be in the completed copy of the notes if you need it. It will be a little bit harder to read. It just ends up being a little bit smaller when you go back to the rest of the Google Doc. But again, you can always pause this video, go back a little bit also if you want to finish filling anything in. And we're actually almost done with our notes for the day. So just trying to get rid of there. There we go. Okay, so underneath that drawing that we just did, there's a really brief sort of definition set of notes here. So it says that similar figures are the same shape, but different sizes. That's really, really important. That's the whole idea of what we're doing. Figures that are the exact same shape and size are called congruent. So if you have two of the exact same triangles, rectangles, whatever, those are called congruent. But anytime that you've taken a shape and enlarged it and kept everything kind of in the same ratio, which we'll get more into definitely over the next couple weeks, or shrunken it and kept it in the same ratio, that's what we're talking about with these similar figures. And we'll do a little activity to investigate that in just a minute. Okay, so under investigate here, last little bit of our notes. How do the side lengths of the similar figures compare? Well, I mean, if you just think about what we did, the first thing that we did trying to work through reducing and enlarging was change the lengths of the sides. So those are obviously different. Okay, you can just highlight, you can underline, whatever you want to do. Okay. Look at the angles in the similar figures. How do they compare? All right, so this is a little more interesting. So obviously in the rectangles, super easy to tell. Those are all right angles, easy peasy. So those are all the same. Now, if you look at the triangle, we definitely have a right angle in the bottom left corner of each of those. And if they were enlarged perfectly correctly, which I hope I did, they should all have the same angles. We're not going to get out protractors or anything like that. For right now, it's good enough for us to just be kind of able to eyeball and compare them. So those are the same. And we're talking about the angles in those similar figures. And that'll be important later on when we start doing more work with these similar figures. Okay, the area of our similar figures. Okay, what was the area in figure A? How did it compare to the area in B and C? We don't need to figure out exactly that pattern going on, but it's enough to say for right now that the areas are different, right? Because they're different sizes. Of course the area is different. And in that same kind of idea, the perimeter is also obviously different because we have two different shaped items, figures, whatever you want to call them. Okay, so this part that we just did with the highlighting, that is important stuff. So make sure you've got those highlighted, underlined, circled, whatever you want to do. Okay, and I'm just going to fill in this last tiny bit, and that is it for our notes today. Okay, so the angles in similar figures are the same. And this is just kind of summarizing what we just did in questions 1, 2, 3, and 4. Okay, so the side lengths, it'd be good if I spelled it right. The side lengths, area, and perimeter of similar figures are different. And that is the important information that you guys need to know to get started working with similar figures. So once you have completed your notes for the day, there's going to be one more link for you guys. I'll make sure it's posted in the stream for you under today's agenda. As long as you're in Zoom, you can also get that. I'll drop that in the chat for you. Just a little bit of extra practice to make sure you guys understand what's going on with these similar figures. Really, really easy. I'm sure you guys are going to be just fine. Just like the other day, if you have a little bit of extra time when class is over today, make good use of that time. Get some of those Dreambox lessons in. Remember, we're aiming for 5 lessons for the week. I know some folks said that they used some of that extra class time from our first class this week, and they got a lot of their lessons or even all of their lessons done already. So make good use of your time. I'm here if you need me. Feel free to ask any questions. And keep up the good work, everybody. Doing awesome.